Some buildings in China shouldn't exist, and yet, there they are, defying gravity, logic, and every rule of conventional construction. We're talking about a bridge so long, it stretches 34 miles across open water. You heard that right, 34 miles, longer than the entire island of Manhattan from tip to tip. These aren't concept renders. They aren't CGI. They are real structures that real engineers said couldn't be built. And once you see what it actually took to make them stand, you'll never look at a building the same way again. And it starts with something that looks like it fell straight out of a science fiction novel. Futuristic cultural landmarks. Picture a building that looks like a crashing wave frozen in steel and glass, not designed, but sculpted. That's the Chengdu Science Fiction Museum. And the moment you lay eyes on it, your brain refuses to file it under building. The structure curves and sweeps in directions that feel physically wrong. Its metallic skin rippling like liquid caught mid-motion. It wasn't designed to blend in. It was designed to make you stop and question whether you're still living in the same world you woke up in. But here's what makes it even more unsettling. The form isn't just aesthetic, it's structural. Every curve you see is load-bearing in a way that traditional architecture simply doesn't attempt. Engineers had to develop custom computational models just to simulate how the building would behave under wind stress. A structure that looks this chaotic on the outside had to be mathematically obsessive on the inside. And that tension between visual madness and hidden precision is exactly what makes it so hard to look away. Then came the most disorienting part. Once the building was finished, people realized it looked different from every single angle. Walk around it, and it shapeshifts. There is no front. There is no predictable silhouette. It is a building that refuses to be fully understood, and that was entirely intentional. Not far away, the Meeresfrog Pavilion takes that same spirit and pushes it even further into the surreal. Where the Science Fiction Museum commands attention through sheer size, the Meeresfrog Pavilion seduces you with detail. It's a smaller structure, but don't let that fool you. Its surface folds and twists like origami at an architectural scale, with geometric facets that catch light differently depending on where you're standing and what time of day it is. It looks less like a building and more like a piece of jewelry dropped into a public square. And this is where something important starts to become clear. These aren't accidents. China isn't stumbling into bold architecture. It is choosing it, commissioning it, funding it, and then building it at a speed that leaves the rest of the world struggling to keep up. But if these two structures made you question what a building can look like, the next one is going to make you question what a building can be. Geometric extremes. You've seen buildings that curve. You've seen buildings that twist. But you have never seen a building that is simply a circle. Not circular in footprint, not round in shape. A perfect, complete ring, standing upright, 33 stories tall, rising out of the ground like a giant golden coin dropped from the sky. That is the Guangzhou Circle, and the first time you see it, your instinct is that someone forgot to finish the design. But this was just the beginning of the engineering nightmare. A ring-shaped skyscraper isn't just unusual, it's structurally catastrophic on paper. Every conventional skyscraper works by stacking weight downward in a straight line. The Guangzhou Circle has no straight line. The forces pulling on the top of that ring are fighting the forces pulling on the bottom, and the tension in between is unlike anything a standard structural system can handle. Engineers had to thread massive steel trusses through the building's core just to stop it from tearing itself apart. Then came the most satisfying part. It worked. The Guangzhou Circle stands perfectly, defiantly, gleaming in jade green glass against the Pearl River skyline, a building that had no right to exist, built anyway. And if a circular skyscraper sounds extreme, the Morpheus Hotel in Macau will completely reset your definition of that word. From the outside, it looks like a tower that someone reached into and carved holes through two massive voids punched through the middle of the building at diagonal angles, leaving the structure looking like it's held together by nothing but stubbornness. That exoskeleton you see wrapping the outside isn't decoration. It is the structure. The building's entire load is carried through that external steel web because the interior is too perforated to bear it. It's the architectural equivalent of removing someone's skeleton and replacing it with a suit of armor on the outside. Every floor plate inside the Morpheus had to be individually engineered to hang from that exoskeleton rather than stack from the ground up. You aren't standing inside a building, you're standing inside a suspended cage that happens to have a lobby and a hotel bar. And once you know that, you can never look at it the same way again. But geometry alone doesn't prepare you for what comes next. A structure that doesn't just defy gravity, it dangles above it. The wheel that floats. Studio City Macau is already excessive by any reasonable standard. A sprawling entertainment complex built to overwhelm the senses from every direction. But none of that prepares you for the moment you look up and see it. Suspended between two hotel towers, hundreds of feet above the ground, is a figure-8 Ferris wheel, not attached to the ground, not rising from a foundation. Just hanging there, golden and massive, locked between two buildings like it was always meant to be there. The scale alone is enough to make your stomach drop. The wheel spans nearly 130 feet in diameter, and it sits at a height that puts most rooftops to shame. But here's what makes it truly unnerving. There is nothing beneath it. No ground support. No central axle rising from the earth. The entire structure is cantilevered off the two towers on either side, which means those towers are carrying the full rotational load of a massive spinning wheel on top of everything else they're already holding up. But this was just the beginning of the structural problem. A Ferris wheel generates dynamic loads, meaning the forces it exerts on its supports change constantly as it rotates. Engineers had to design connection points between the wheel and the towers that could absorb those shifting forces without transmitting vibration into the hotel rooms below. If they got it wrong, guests on the upper floors would feel the wheel turning every time they tried to sleep. Then came the most staggering part. They got it exactly right. The wheel turns smoothly, silently, and the towers don't flinch. You can ride it hundreds of feet above Macau, looking out over the Pearl River Delta, with nothing below you but open air and the distant glitter of the city. All because a team of engineers decided that structurally impractical was just another problem to solve. And if suspending a Ferris wheel between two buildings sounds bold, what comes next makes that look like a warm-up act. Engineering that broke records. The CCTV headquarters in Beijing looks like someone bent a skyscraper into a loop and forgot to straighten it back out. Two towers lean toward each other at impossible angles, 6 degrees off vertical, and then connect at the top through a massive L-shaped overhang that juts 98 feet out into open air with nothing underneath. Every structural engineer who first reviewed the design said the same thing: this building will fall down. But the tension didn't stop at the design phase. When construction reached the point where the two cantilever arms were extended and ready to be joined, engineers realized the two sides had shifted slightly due to temperature changes in the steel. The connection point was misaligned by several inches. Joining them incorrectly would lock catastrophic stress permanently into the structure. They had to wait monitoring the building around the clock for a specific weather window when temperatures would cause the steel to expand just enough to bring the two arms into perfect alignment. Then, in that narrow window, they bolted it together. The payoff is a building that now stands as one of the most recognized skylines in the world. A twisted loop of steel and glass that rewrote what corporate architecture is allowed to look like. Then came Leeza SOHO, and it broke a different kind of record entirely. The building twists as it rises, rotating a full 180 degrees from base to top, and at its center is an atrium so tall it claimed the world record for the highest indoor atrium ever built, soaring over 690 feet from floor to ceiling. You heard that right. Nearly 700 feet of open vertical space inside a single building wrapped in a spiral of glass. But the engineering marvel isn't just the height. It's the fact that the building twists around that atrium without ever compromising its structural integrity. Every floor plate rotates slightly relative to the one below it, which means no two floors are perfectly aligned, and yet the whole thing holds together with the precision of a watch mechanism. And then, when you think Chinese engineering has shown you its ceiling, it takes you to the water and builds something that makes every skyscraper on this list look small. The bridge beneath the sea. 34 miles, That is the length of the Hong Kong-Zhuhai Macao Bridge, and if that number doesn't immediately land, here's what it means in real terms. You could drive across it for over half an hour without stopping, and you'd still be on the same bridge. You heard that right. It is the longest sea crossing ever built, stretching across the Pearl River Delta and connecting three of the most economically vital cities in southern China with a single unbroken ribbon of road. But here's where the engineering becomes genuinely extraordinary. Halfway across that bridge, you disappear. The road dips below the surface of the water and becomes an immersed tunnel 4.2 miles long, buried under the sea floor because the shipping lanes above are too critical to block with a bridge structure. Massive cargo ships need to pass overhead, while cars travel silently through the tunnel beneath them. Two completely different worlds, separated by a thin layer of sea and engineering genius. Building that tunnel meant prefabricating 33 concrete tube segments on land, each one as large as an apartment building, then sinking them one by one to the sea floor and connecting them with watertight precision in conditions where visibility was near zero. A single misaligned joint would have flooded the entire section. There was no margin for error, no second attempt, no safety net. Then came the most breathtaking part of all, the transition. As a driver, you approach the tunnel entrance on an artificial island, one of two islands built from scratch in the middle of the sea just to manage the bridge-to-tunnel handoff, and then you descend smoothly beneath the waves, while container ships the size of city blocks pass above you without ever knowing you're there. This is not infrastructure. This is a reordering of geography itself. Monumental venues. You've seen buildings that defy geometry and bridges that swallow the sea. But some structures don't just challenge engineering, they redefine what it means to gather. The Beijing National Stadium, known worldwide as the Bird's Nest, is exactly that kind of place. From a distance, it looks like a massive tangle of steel beams thrown together at random. Up close, you realize every single beam is exactly where it needs to be, interlocked, load-sharing, and collectively holding up a structure that seats 91,000 people without a single interior column blocking anyone's view. But the tension was always in the construction. Welders worked around the clock, joining steel members at angles that had never been attempted at this scale. The structure had no straight lines, no repeating patterns. Every connection point was unique, which meant every connection point had to be individually engineered and individually built. Then the stadium opened for the 2008 Olympics, and the world went silent for a moment, not because of the athletes, because of the building. A structure that looked impossible had become the most photographed sports venue on Earth. Not far behind it, the Longgang Stadium pushes the idea of a roof to its absolute limit, a sweeping canopy that stretches over the seating bowl like a wave frozen mid-crash, supported by the slimmest possible structural frame. And the Zhuhai Grand Theater takes it even further. Two shell-shaped towers rising from a coastal platform, like something the ocean itself exhaled onto the shore. At night, lit from within, they glow against the water like lanterns, beautiful, improbable, and completely real. But monumental venues are one thing. What happens when an architect looks at nature itself and decides to use it as a building material? Nature meets architecture. Most buildings fight their surroundings. They clear the land, pour the concrete, and impose themselves on whatever was there before. 1,000 trees does the opposite, and the result looks less like a building and more like a hillside that decided to go vertical. Columns shaped like tree trunks rise from every terrace, each one topped with a planter, so that the entire surface of the building is covered in living vegetation. From across the street, you don't see a shopping complex. You see a forested mountain sitting in the middle of Shanghai. But the engineering underneath that organic surface is anything but natural. Every column had to be designed to carry not just the structural load of the floor above, but the additional weight of soil, water, and full-grown trees loads that shift with rainfall, wind, and seasonal growth. The building is essentially a living organism bolted onto a concrete skeleton. And keeping those two systems in balance required engineering that most architects wouldn't attempt. Then came the most quietly staggering part. It worked so well that birds began nesting in the trees on the upper floors. A building in the middle of one of the world's most densely populated cities had quietly become a habitat. And then there's the intercontinental Shanghai Wonderland, which didn't just integrate with nature, it descended into it. Built inside an abandoned quarry, nearly 300 feet deep, the hotel drops below ground level rather than rising above it. 16 of its 18 floors sit underground, with rooms carved into the quarry walls, looking out through glass at a waterfall cascading down the rock face. It is the only hotel in the world where checking in means going down. Most engineers said the geology alone made it unbuildable. Groundwater pressure, unstable rock faces, and the sheer complexity of constructing inside a pit rather than on flat ground pushed every conventional method past its limit. But this was just the beginning of what China was willing to attempt when the landscape itself became the canvas. Because next, the landscape doesn't just get used, it gets completely, permanently transformed. Infrastructure that moves mountains. There are structures that impress you. And then there are structures that quietly rearrange the world. The Three Gorges Dam belongs to the second category. Stretching 1.4 miles across the Yangtze River, it is the largest power station ever built by human hands, generating as much electricity as 22 nuclear power plants running simultaneously. You heard that right. One dam. 22 nuclear plants worth of power produced every single day. But the scale of what it took to build it is where the tension truly lives. Over 1 million people were relocated to make way for the reservoir it created. Entire cities disappeared underwater. A stretch of river that had defined Chinese civilization for thousands of years was permanently altered in less than a decade. The engineering was almost secondary to the sheer human weight of the decision to build it at all. Then came the payoff that the numbers alone can't fully capture. The dam works. It controls flooding along a river that once killed hundreds of thousands of people in a single season. It powers hundreds of millions of homes. It is brutal, enormous, and completely transformative. A structure that didn't just cross a river, it rewrote the river's role in an entire nation. And if the Three Gorges Dam shows you what happens when China reshapes its waterways, the Yangtze Expressway shows you what happens when it decides the mountains are next. This highway doesn't go around the peaks of southern China, it goes through them, over them, and sometimes appears to float beside them. Viaducts stretch between cliff faces at heights that make commercial aircraft feel low. Tunnels bore straight through rock that no road was ever meant to cross. From above, the expressway looks like a brushstroke drawn freehand across a vertical landscape. But the payoff is a drive that feels less like commuting and more like flying with asphalt beneath you and nothing but open mountain air on every side. Masterpieces that close the loop. By this point, you've seen buildings that loop, bridges that vanish underwater, hotels buried in quarries, and dams that swallowed cities. But China saved two of its most quietly devastating architectural achievements for last. The Guangzhou Opera House sits on the northern bank of the Pearl River like two boulders that the water deposited there and forgot to move. Designed by Zaha Hadid, the structure has no hard edges, no flat faces, no straight lines anywhere in its exterior. It flows. It folds. It looks, from certain angles, like it grew there rather than was built. But building something with no straight lines is an engineer's nightmare. Every panel of the exterior cladding is a unique shape. Every joint connects surfaces meeting at angles that standard construction tools aren't designed to handle. Workers had to use digital fabrication techniques that barely existed when the project began, essentially inventing new construction methods on the job site in real time. Then came the most satisfying payoff of the entire video. Step inside, and the acoustics are flawless. A building that looks like pure sculpture performs like a precision instrument because Hadid refused to separate beauty from function. Every curve that makes it visually extraordinary also serves the sound. And finally, the China Resources Tower in Shenzhen, a 1,115-foot super tall that earns its place on this list not through gimmickry, but through sheer structural ambition. The tower's tapered form required a mega-column system so advanced that the engineering team had to run climate simulations just to account for how wind pressure at that height would affect the building differently across seasons. These structures, every single one of them, were called impossible before they were called finished. Engineers said no. Physics seemed to agree. And then China built them anyway, taller and bolder and more precisely than anyone thought the laws of the physical world would allow. The buildings you just saw don't exist because someone got lucky. They exist because someone refused to stop at the point where everyone else did. What China proved possible. You've made it to the end of this list, but before you close this video, take a second to sit with what you just witnessed. Not a collection of pretty buildings, not an architectural slideshow. What you actually just watched was a systematic dismantling of the word impossible. Think about what that actually means. Every single structure in this video, every twisted tower, every buried hotel, every ring-shaped skyscraper, every bridge that ducks beneath the sea started as a drawing that made experienced engineers shake their heads. The Guangzhou Circle was structurally suicidal on paper. The CCTV headquarters had to wait for the perfect temperature window just to be bolted together. The Morpheus Hotel removed its own skeleton and replaced it with armor. The Hong Kong Zhuhai Macao Bridge built artificial islands in the middle of the ocean just to solve a design problem that no one had ever faced before. And none of that happened by accident. China didn't stumble into becoming the world's most ambitious builder. It made a deliberate, calculated, almost aggressive decision to treat architecture and engineering not as a service, but as a statement. Every one of these projects was greenlit, knowing it would be harder than anything that came before it. Every one of them was funded, staffed, and driven forward, past the point where any reasonable person would have stopped and asked whether it was worth it. But here's what makes it truly staggering. The pace. The Three Gorges Dam, the world's largest power station, was completed in under a decade. The Hong Kong Zhuhai Macao Bridge, the longest sea crossing ever built, took 9 years from groundbreaking to opening. Leeza SOHO, with its record-breaking 700-foot interior atrium spiraling inside a twisting tower, was delivered on schedule. Structures that should have taken generations were finished in the time it takes most countries to approve a planning application. And while the rest of the world was debating whether these things were possible, China was already moving on to the next one. That's the part that should genuinely unsettle you, not just the scale of what was built, but the relentlessness of it. Because the buildings you saw today aren't the ceiling. They're the foundation. Every impossible structure that gets built raises the floor for what comes next. Every engineer who figured out how to suspend a Ferris wheel between two towers, or sink a tunnel beneath a shipping lane, or grow a forest on the side of a skyscraper, walked away from that project knowing something the rest of the world doesn't know yet. And they're already using it. So the next time you see a rendering of something that looks like it was designed by someone who never studied physics, don't assume it's fiction. Because somewhere, right now, there is a team of engineers in China looking at that same drawing, nodding slowly, and figuring out where to pour the first column.